Hello everyone, this is Adish. I'm a grade 10 student from Mumbai. So today's problem is decide the winner. The difficulty level of this problem is simple because you only need to know bit manipulation in order to understand my solution. So in this problem, we're basically given two players of the game, Alice and Bob. The game is as follows. Alice starts the game and Bob gives Alice a number. If the number is a power of 2, Alice divides it by 2 and then Bob plays. And if the number, they basically keep dividing the number by 2 if it is a power of 2. However, if it's not a power of 2, they will subtract the highest power of 2 and switch turns, and they'll continue this until only the number 1 is left. Once 1 is left, the next player who gets the number 1 cannot play any further, and that player who gets the number 1 loses the game. So for example, let's say that there is a test case where n is 1 and Bob gives Alice 1. This means that Alice cannot make any move. That's why Bob will win. And in the second example, where you consider the number 6, then since 6 is not a power of 2 and 6 is 2 squared plus 2 raised to 1, that's basically 1, 1, 0 in base 2. This means that we need to remove the highest power of 2 from the number. We need to subtract the highest power of 2, and we basically subtract 4, so we get 2. So Alice basically gives Bob, so this is when Alice is playing, then Bob gets 2, and 2 is just 1, 0 in base 2, and hence Bob gets this number, and this is a power of 2, this is not a power of 2. So since there's more than one set bit, this is not a power of 2. However, this has only one set bit, which means that it is a power of 2, and that's why Bob will have to divide by 2 to get the number 1. And once he gets the number 1, he will basically give it to Alice, and hence Bob wins because Alice has the number 1, and it's Alice's turn. So you can read the example which says exactly the same thing which I said, and basically this is how the game works using these two examples. Now let's try to find out a way to simulate the game, and the simulation will use some bit manipulation tricks such as finding the highest set bit, the lowest set bit, and to notice that subtracting the highest power of 2 is essentially removing the highest set bit, and the number is a power of 2 when there's only one set bit. So let's make some observations based on the criteria of bit manipulation, and basically notice that the number has at most 64 bits. So it will fit in a long and you will need to have a loop of at most 64 to iterate through each bit. So now let's move on to the observations. So the first observation is that the number, you will keep removing the highest set bit. The players will keep removing the highest set bit from the number if as long as the number has more than one set bit, as long as the number of set bits is greater than 1. And this basically means that if you consider the bit representation, let's the base 2 representation, basically let's consider an example where this is the base 2 representation, and let's say that there are basically 1, 1, 2, 3, 4 and 5. There are 5 set bits. So since there are 5 set bits, we know that the players will take 4 operations in order to 4 turns, basically one by one, 4 times they will have to remove the highest set bit. So first Alice will remove this set bit, then Bob will remove this set bit, then Alice will remove this set bit, then Bob will remove this set bit. Now the number which is left is going to be the number with only one set bit. The number which remains has only one set bit, and hence it's a power of 2, and hence we can basically find out what is the power of 2. we can find the base, we can find the exponent, uh, I, let's call it I, or let's call it Paul's, 2 raised to Paul's. The number is 2 raised to Paul's. And in this case, the value of Paul's is 0. But let's say that, let's just add a few more zeros. So let's add a few more zeros. In this case, the value of Paul's will be 0, 1, 2. So the value of pause is 2. Let's consider an example where pause is 2. So in this case, the number of set bits was 5, which is why you need to perform 5 minus 1, which is 4 operations, and the turns will alternate 4 times basically, and again you get back to Alice. Now the key observation is that, let's not use pauses 2 because that's an even number. And we know that something interesting will happen, but let's just consider the example where pause is 3. I'll explain in a bit why. But basically, when pause is equal to 3, what happens is that you are basically you're basically dividing by 2 as many number of times as the number is greater than 1. Because it's a power of 2, you keep dividing by 2 and keep changing the term. So that basically means that if pause is 3 and the number is 2 raised to 3 and it's Alice's turn, then Bob will make it 2 raised to 2. Alice will make it 2 raised to 2 and give it to Bob. Then Alice will get 2 raised to 1 and Bob will get 2 raised to 0, which is 1. And this means that Alice wins. So whenever pause is odd, and there have been an even number of operations, then we know that Alice wins. However, if pause is even and there have been an even number of operations, then Bob will win, because if you consider an example where pause is 2, in that case Alice will get 4, Bob will get 2 raised to 1 and Alice will get 2 raised to 0, which is 1, which means that Bob wins. So if pause is even and there have been an even number of operations before, then Bob wins. However, if the number of operations is odd, which means that the number of set bits is even, in that case, if pause is odd, Bob will win, and if pause is even, Alice will win. Basically, the inverse happens. And using these cases, we can figure out the number of moves. So let's just generalize this and not consider the 4 cases, because that makes it a bit messy casework. Let's just consider the number of turns in the game, the number of moves in the game, and the number of moves in the game is simply calculated by the 2 operations which happen, step 1 and step 2. Step 1 is deleting until there's only 1 set bit. So step 1 has number of set bits minus 1, and step 2 has basically the lowest set bit, the position of the lowest set bit, that will be the number of operations which are there in step 2, and therefore total number of moves will be given by the sum of these two, which is the count of set bits plus the lowest set bit, and hence you can find this count of set bits plus the lowest set bit minus 1. And if this is odd, then if the total number of moves is odd, then we know that the Alice will win, basically, because Bob gets the number 1. However, if the total number of moves is even, then Alice gets the number 1 again, and that's why we know that Bob will win in that case. So in the first case, Alice will win, and in the second case, when the total number of moves is even, Bob wins. And now we can just do this in the actual code using simple bit manipulation. So I'll show you the code in C++. So in the accepted C++ code, we basically taken the value of p, which is the number of test cases. While the number of test cases is not equal to 0, we will take an n using long. We'll set the turn to be 0 and count set to be 0 and min set bit to be 64, and we will iterate through each bit. If the bit is set, we'll increase count set by 1 and we will minimize the min set bit. Then what we'll basically do is compute the number of turns, and if the number of turns is even, we know that Bob wins, otherwise Alice wins. And I use fast IO because you can get a TLE if you don't use fast IO. So this is the fast IO pseudocode. This is the fast IO template. And the general idea is that for the first count set bit -1 turns, they'll keep removing the highest power of 2. Then only one set bit is left, which represents the lowest set bit, and that lowest set bit will be the power of 2. So you keep dividing by 2 for that many number of times, and hence this is the total number of turns which you can compute in just 64 operations for each test case. So the time complexity is 64 into the number of test cases, which is up to 640, which will easily work in 1 second. So you can verify that the code gets accepted comfortably within 1 second. And I hope you like this problem and my solution. If you have any doubts in any part of the solution, do leave them in the comments down below. And if you like this video, don't forget to give it a thumbs up. Thank you.